Hi there, Mr. Temp.
Hello, Smart. What's that new interesting connection you've got?
Well, not long ago I had some corrosion on my terminals, and all the control room could see were some useless values instead of the real process temperatures. Then, all of a sudden, they realized what was happening, and the whole system was switched off. At last, a service technician decided to turn up. I had a funny feeling he was going to exchange me. But no, instead I was fitted out with a real useful addition, a temperature transmitter from Endress & Hauser.
So what can he do?
Quite a lot. He controls all communication between me and the control room, and that's far safer and more precise.
Safer and more precise? I've experienced a lot of measurements in my lifetime, and all of them were safe and precise. You say it can be done a lot better though by using transmitters? You'll have to explain that a little better.
With pleasure. Due to the transition resistances, my transmitter recognizes terminal corrosion. He lets the control room know what has happened before faulty values are used, without even being recognized as such, and at some point even causing the system to crash. But anyway, there's no possibility of corrosion on my gold-plated terminals. Transmitters are always more accurate. In some areas, there's still the opinion that due to the extra ADDA conversion, they're more inaccurate than directly wired temperature sensors. That's a real fallacy, because the sum of the analog errors that occur in direct wiring is greater. I'm not just thinking about the errors on a 2 or 3 wire PT100 connection. Just look at the inaccuracies in thermocouple measurement, for example, due to thermal voltages on transmission points, plugs, or even compensation cables. How often has this gone unrecognized? Now there's an end to all that.
Understood. And best of all, it seems to me, is that the system doesn't need to be interrupted. The plant remains available at all times. Transmitters make the system safer. And higher precision, of course, guarantees better process quality. So, all in all, transmitters help to keep costs down too.
Of course, Mr. Temp. Modern transmitters can be configured and support all commonly used thermocouples and resistance sensors. The curves for all sensor types are stored in the transmitter, so that the highest possible accuracy can be achieved. In addition to this, the accuracy of the complete measurement chain can be increased by using a specific sensor-transmitter matching system. That can be done for us either by Endress & Hauser in its calibration laboratory, or we do it for ourselves using our own block calibrator, thanks to the free software tool. Apart from the savings made in the process, the purchase of a transmitter-based system is mostly a lot more economical. Sensitive and expensive thermocables or compensation cables are a thing of the past. There's also no longer a need for long 3 or 4 wire cables for the PT100s. We can now use the same robust copper cables that we use in the rest of our measurement and control applications.
That means temperature measurement points no longer need any special treatment. So they can now be easily integrated into the system?
Yes. Transmitters can communicate using standard 4 to 20 mA boards, HART, Profibus, or FF. These input boards cost a fraction of the temperature input boards that need to be used when direct wiring. So this makes the buying and maintenance of the measurement and control system a lot more economical. Because everything is standard, spares can be used with more flexibility, resulting in a reduction of stock items. Even the engineering process becomes simpler, quicker, and cheaper.
Communication is important, and in today's world shouldn't cost the earth. And anyway, all other measurement values, such as pressure and level, communicate using these standard signals. I'm sure I've got a far too expensive card contract. Do you think I could change to Endress & Hauser?
Of course. The Endress & Hauser transmitters are fully compatible with all international standards. In the meantime, we see quite a lot of changes from thermocouples to PT100s. When using a transmitter, it's easy just to set it up to suit. The rest of the system remains unchanged. In the old days, sensors, cables, and input boards needed changing, and then there was the system reprogramming. No wonder that most people shunned away from this effort. It's even possible that the transmitter simulates and transmits a fixed value when the sensor element is being changed. That means that the plant will continue to run.
So we are talking about total cost of ownership. But let's go back to the beginning. A fault on plant, for example a voltage surge. What happens with EMC? Is the system also better protected by inserting a transmitter?
Just so, Mr. Temp. There's better protection and the danger of faulty measurements is reduced. Even ground loops are avoided due to the transmitter galvanic isolation. Anyway, Mr. Temp, did you know that due to the large amount of programming required in direct wiring, advanced diagnostics is only possible with transmitters?
Sure, Smart. But what do I want with advanced diagnostics?
Using bus protocols, transmitters deliver, in addition to temperature information, further details regarding the condition of the measurement point condition. This could be a broken sensor. With advanced diagnostics, the user can operate and maintain the system even without specialized sensor know-how and without needing to be a temperature specialist.
That explains why the SIL 2 safety standard is possible with a transmitter and can't be fulfilled with direct wiring. Transmitter technology simply means state-of-the-art instrumentation.
Yes, great, eh? The technical precision and flexibility of transmitter technology helps to produce the best possible quality of the end product. Standardized signals are usable in all systems, leading to easier and optimum process control. In the end, using transmitters leads to an increased plant efficiency.
Mr. Smart, I can see you're smart by name and smart by nature.
Hey, thanks, Mr. Temp. Endres & Hauser develops, produces and assembles all key components of a temperature measurement point in-house. This begins with the primary sensor, followed by measurement inserts, complete thermometers, as well as thermowells and process connections, up to a complete range of transmitters of various designs and communication standards. All these individual components are compatible with each other and, of course, with all important worldwide standards. Our Process Solutions Centers offer reliable and state-of-the-art complete solutions in the field of process and automation technology. In addition to on-site consultation and service in all time zones, we offer a unique and innovative online support strategy, the WAM portal. It assists in the correct planning and configuration of all types of measurement points, from simple applications up to complex plants. It also supports you with a database from which all relevant information and documentation for your products can be called up at any time. Our knowledge of the industry and our long years of experience have brought us to where we are today. Use our state-of-the-art solutions from the people for process automation for your company's success.